Hi, Stella. Hope you all are feeling well. We've been covering parallel and perpendicular lines this week. I'm just going to run through a quick explanation of perpendicular. I think you were here for the parallel stuff that we did early last week, but let me run through a couple problems, or one problem anyway. So we talked about parallel lines and how parallel lines have the same slope. If I gave you this equation, y equals 2/3 x minus 5, you know how to graph that. We go down 5, up 2 over 3, up 2 over 3, and so on. And I could find a line that's parallel to that. In fact, I could find infinitely many lines that are parallel to that line. All they have to have is the same slope. They'd all have a different y-intercept, but they'd have the same slope. So if I asked you randomly, find me the equation of a line that's parallel to 2/3 x minus 5, you could say y equals 2/3 x plus or minus anything, and that would be parallel. If I asked you more specifically, find me the equation of the line parallel to 2/3 x minus 5 that passes through the point 6, 7. There's only one line, one specific line, that passes through that point and is parallel to 2/3 x minus 5. So here's the point 6, 7, and the only line that passes through that point 6, 7 and is parallel to y equals 2/3 x minus 5 is this line. Well, I could find the equation of that line. Sometimes I can count down and over to find out what that y-intercept is, but I can also do this using our point-slope formula. Sometimes that y-intercept doesn't go exactly through a corner point. So what I want to do is use the point-slope formula, which is our y equals m, that's 2/3 in this case, the same slope as the original line, times x minus that x value, so minus 6, and then plus that y value, so plus 7. And then I'm just going to do the arithmetic out. This point-slope formula, sometimes that's enough. Sometimes that's all we need. A lot of times, though, problems will say put it in slope-intercept form. So they want to put it in that y equals mx plus b form. And if that's the case, we're going to distribute and combine like terms. So that would be y equals 2/3 x. If I distribute 2/3 of 6, this is where we do the 3 goes into 6 twice, and 2 times 2 is 4, so minus 4 plus 7, which is y equals 2/3 x minus 4 plus 7 is plus 3. And that makes sense on my graph. That y-intercept is right there, right about the 3. I didn't sketch that first line exactly correctly, but so that's parallel lines. If we need the equation of a line, we just use that same slope. Perpendicular gets a little bit more complicated. With perpendicular lines, we have to have two things happen. Perpendicular lines have slopes that are both opposite in their sign and reciprocal, so they have to be both of those things. For example, if I gave you told you that a line had a slope of 2/3, like in that last problem, slope of 2/3 would be up 2 over 3, and it would continue that way no matter what the y-intercept is. There's a line with a slope of 2/3. A line that's perpendicular to that doesn't just have a reciprocal slope of up 3 over 2, and it doesn't just have an opposite sign of negative 2/3. It has to have both of those things. So the slope of the line perpendicular, we have a little symbol for perpendicular, it's an upside down capital T, would be the opposite sign, so negative 3 over 2. And again, I could start anywhere here. Let's say I start I'll start right here. From that point, if I go up 3 and then 2 to the left, now I have an exact perpendicular line to the first line. And perpendicular, again, means it meets at a right angle, it meets at a 90-degree angle. We don't talk too much about angles in Algebra 1. That's kind of a geometry topic. We talk about slopes, and those slopes are opposite and reciprocal of each other. If the slope was, let's say the slope was 4, the opposite slope, or the opposite reciprocal slope, the perpendicular slope, would have to be negative 1/4. So 4 over 1 becomes negative 1/4. So if I told you to draw a line, any line perpendicular to y equals negative 3/4 x plus 2, that plus 2 with these perpendicular lines, that doesn't mean anything to us. It just happens to be the y-intercept of the line we were given. I want you to draw any line that's perpendicular to y equals negative 3/4 x plus 2. Well, that could be anything, but its slope would have to be, the slope of the perpendicular line would have to be now a positive 4 over 3. I could start at that same y-intercept. I could start anywhere. Let's say I start at the origin. My new slope is up 1, 2, 3, 4 and over 1, 2, 3. Here is my new line that's perpendicular to the one we were given. And my pen will not record that, but you kind of get the idea. And there we go. That's kind of what it looks like. Again, it meets at a right angle to that original line. And in this question, find me any line perpendicular to. Y-intercept could be anything. But the slope has to be positive 4/3. So like in the first question, I'm going to extend this now and say a little more specifically, find me the equation of a line that's perpendicular to y equals negative 3/4 x plus 2 that passes through the point 6, 7. So I'm looking now not for any line perpendicular to, but for the only one line that passes through the point 6, 7. And we'll again put this one in slope-intercept form, so y equals mx plus b. For some reason, my y-axis is not lining up right on line, but you get the idea here. So I've drawn that line y equals negative 3/4 x plus 2. Again, I don't really need it for anything, except I can kind of visually see if my, my new answer is going to be right. I'm going to go to the point slope formula again. Y equals, now in this case, my new slope, again, that perpendicular slope should be positive 4/3. And then I'm going to plug in the 6 and the 7, x minus 6 plus 7. So let's see, that would be y equals 4/3 x. 3 goes into 6 twice, 2 times 4 is 8. So minus 8 plus 7, which gives me a final answer of y equals 4/3 x minus 1. Let's see if that makes sense from my graph. I can do this a couple ways. I can start at that point and do the slope of 4/3. I could go up 4 and over 3, or I could go down 4 and over 3, because I'm aiming for that y-intercept, and there's my y-intercept of negative 1. And I can see that looks pretty perpendicular to the line I was given. Or I could take this equation, start at the negative 1, count up 4 and over 3, and I can end up on that 6, 7 and see that that's where it ends up. All right, so perpendicular lines have to be both the opposite sign and the reciprocal. When I was in school, we used to say negative reciprocal, but now we say opposite. One of them should be positive, one of them should be negative. Couple little things. If you had two equations, let's say y equals 3 and x equals 2, those two lines would be perpendicular to each other. Y equals 3 is a horizontal line, and x equals 2 is a vertical line. And vertical and horizontal are definitely perpendicular to each other. So if those equations look a little weird, that's okay. One of them could be horizontal, one could be vertical. I think the Desmos that we did for the snow day, I deliberately gave you giant points, giant coordinate points, because I wanted you to know that sometimes it's okay to just leave it in point slope form. So I think the equation of some of those lines was 2, and it's okay sometimes to say x minus 294 plus 300 or whatever the coordinates were. That's an okay line. I don't need you to always distribute and clean it up. So we want to watch the directions, and the directions just said find an equation of the line, and point slope is an equation. Because in that question we're looking for a rectangle, your other equation might be y equals. We need perpendicular lines for a rectangle. So x minus whatever and then plus whatever. Okay? So that's perpendicular in a nutshell. It's opposite and reciprocal. And then we're just going to practice them. My plan this week is review Monday, Tuesday, and then a 2-day test, because I used to give this test in 1 day and it was always too long, so I spread it out over 2 days. All right, hope you all are feeling better, and I'll talk to you soon. Bye-bye.